Hello， 你好，我是 Frank， 你的飞行伙伴。ATR-72 涡轮螺旋桨飞机是我们台湾国内线航空公司的主力客机。那你想驾驶 ATR-72 涡轮螺旋桨飞机吗？你想知道 ATR-72 飞机系统的设计吗？我来介绍一位曾经在台湾飞行过的资深 ATR 机长，叫 Magnar Nordal。他的频道 Fly with Magnar 有一系列关于 ATR 飞机系统的专业讲解哟。要是英文对你来说没什么问题，那赶快 YouTube 搜寻 Fly with Magnar 进去他的频道看看吧。记得给他按赞、分享和订阅哟。但要是原文英文加上一点欧洲口音，又没有字幕，你会有点吃力，甚至根本听不懂。没有关系，好消息是，感谢 Magnar 机长让我以加上中文字幕的方式，在飞行伙伴频道里分享给各位朋友们。在飞行伙伴里的 ATR-72与 Magnar 机长飞翔系列里，可以陆续了解 ATR 各项系统和驾驶舱的操作哟。那我就不多说啦，我们直接来看看吧。
Hi, my name is Magnar Nordal. I'm a captain instructor on ATR aircraft. This video is about the instrument panels and their controls in ATR variants with glass cockpit. The instrument panel is dominated by 5 LCD screens, which are called display units, or DUs. They are numbered 1 to 5 from left to right. In front of each pilot there are 2 display units, the PFD, primary flight display, and the MFD, multifunction display. In the center of the panel, there is an EWD, engine warning display. The screens are identical and can be inserted in any of the 5 positions. Each screen has a power push button, a brightness button, and a contrast button, which controls the brightness of the weather radar image and the terrain map. And behind the panel door is a slot for the memory card with database of all airports, navaids, departures, airways, arrival, approaches, and terrain around the world. 2 of the display units, number 2 and 4, can be powered by batteries alone. They also house the flight management system, the FMS, and the radio management system, the RMS. The FMS and the RMS are controlled with the MCDU, the Multi-Purpose Control and Display Unit. The aircraft has 2 MCDUs. The left MCDU, number 1, is normally connected to FMS number 1 and RMS number 1. And MCDU number 2 is of course connected to FMS number 2 and RMS number 2. The systems are interconnected. Any change you do to one FMS or RMS is automatically transferred to the other. This is called crosstalk and ensures redundancy. The flight management system is a Thales FMS 220. It has the following functions. 1. Determine the position of the aircraft. 2. Manage aircraft weight, center of gravity, fuel quantity, and cruise level. 3. Manage a flight plan. 4. Predict fuel and time along the flight plan. 5. Provide lateral and vertical navigation guidance to the autopilot system. The RMS is used to control radios, navaids, transponder, and TCAS. Here are the PFD and the MFD on the captain's side. On the first officer's side, the displays have switched side. But here I will show the captain's side. We start with the PFD. At the center of the PFD, we have the attitude display indicator, the ADI. It shows pitch and roll. The airplane is now flying with wings level and about 1.5 degrees nose up, which is typical for cruise. Indicated airspeed is 188 knots, which is also the target speed shown with this number and bug. Magenta color indicates that the target speed is calculated by the FMS. The panel outside the PFD is called the ICP, the Index Control Panel. Here you can switch between automatic and manual target speed. Manual target speed is shown in cyan color and is used when you cannot use standard speeds, for example when ATC tells you to reduce your speed during approach. The altimeter shows 17,990 feet, which is close to the target altitude, which is flight level 180 or 18,000 feet. It is shown with a cyan number and bug. Flight level means hundreds of feet when the altimeter reference pressure is set to standard, shown as STD. When we descend towards the airport, we change the reference to local pressure, called QNH. It is set when we rotate this knob. When we push on the knob, the reference is set to standard, which is 1013.25 hectopascal or 29.92 inches mercury. MDA is used to set minimum descent altitude, which is minimum altitude we can descend to during approach without having visual references. It is set with this double knob. The inner knob is used to select between DH, decision height, which is used for ILS Cat2 approach with reference to the radio altimeter, and for all other approaches, MDA, minimum descent altitude, with reference to the barometric altimeter. Outside the altimeter is the vertical speed indicator. Here is the status of the TCAS, Traffic Collision Avoidance System. Below means that traffic from 2,700 feet above down to 9,900 feet below the airplane are shown on the navigation display on the MFD. Currently, we see no traffic. Below is the status for the transponder. ALT means that the altitude reporting is on, allowing ATC to see your altitude on the radar screen. Above the ADI is the FMA, Flight Mode Annunciator. Icing AOA means that the minimum speeds are increased to compensate for any ice that may form on the wings and therefore increase the stall speed. AP means that the autopilot is on. FD means that the flight director is active. The flight director computes horizontal and vertical steering commands that are shown as two green bars on the ADI. When engaged, the autopilot follows those commands. The green arrow points to which side, captains or first officers, the flight director is coupled to. ALT means that altitude hold mode is engaged. ELNA means that the flight director is following navigation information from an FMS, Flight Management System. The airplane has two FMS. I will come back to them soon. Below the ADI is the Horizontal Situation Indicator, the HSI, which shows heading and navigation information. Selected heading is 346 degrees and shown with a cyan number and bug. Since this is the captain's instrument, we see navigation information from FMS number 1. The magenta CDI shows that we are on correct track. The next waypoint on the route is ABPSL. The bearing is 340 degrees. The distance is 42.1 nautical mile. At the bottom, we have two boxes with NAVAIDS information. Nav 1 is tuned to an ILS with frequency of 110.3 MHz, and the distance is 127 nautical miles. Nav 2 is tuned to another ILS, and the distance is 78.7 nautical miles. Before I start to describe the MFD, the multifunction display, I will show you the EFIS control panel, the EFCP. It is located on a pedestal and has individual controls for both MFDs. The 6 push buttons are used to select different pages on the MFD, where navigation, aircraft systems, and performance are most important. I will come back to them soon. Next, we have controls for the navigation display, which I will describe very soon. And finally, we have controls for the alert and procedure window on the EWD. I will talk about that later. The navigation display, the ND, is selected by pressing the ND push button on the EFIS control panel. In the upper left corner, we have true airspeed, TAS, ground speed, GS, and the wind, which is from 085 degrees at 20 knots. The arrow shows the direction of the wind relative to the heading of the aircraft. The heading bug is manually set to 346 degrees. Actual heading is commanded by the FMS and is 345 degrees, and the track is 340 degrees, shown with magenta diamond. This is the navigation source, in this case a GPS. For backup, the FMS can use VOR, DME, and dead reckoning. The next waypoint on the route is ABPSL. The bearing is 340 degrees. The distance is 42.1 nautical mile. And we will reach this point in 9 minutes and 44 seconds. On the navigation display, we can see that the weather radar is active. There is no weather. And this little green dot is a mountain peak in Ramkhamhaeng National Park, southwest of Sukhothai Airport. I just know that. We can also see that airports and navigation are shown. The format knob is used to toggle between 3 navigation display modes. Arc mode, as shown here, rose mode with a full compass, and the planning mode, which is used when you check the flight plan route in the FMS against the charts. In planning mode, the screen is oriented to the north. The range of the display is set to the range push buttons on the airfield control panel. Here, the range is 80 nautical miles. The 2 rectangles are identical for those on the PFD, and here they show ILS frequencies. When a VOR frequency is active, a pointer will appear on the ND and the HSI as well when the aircraft is within range of the VOR, just like an RMI. On the airfield control panel, there are bearing push buttons you can use to toggle between VOR ILS or ADF or no indication at all. When the ND page is replaced by another page, the navigation display is transferred to the PFD. This is called mini ND. The CDI from the HSI is maintained, so the display is a bit cluttered. The system push button is used to toggle between 4 different pages: the AC wild and hydraulics page, the engine secondary page. The primary engine indications are permanently displayed on the engine warning display, the cabin page, and the AC/DC electrical page. If you want to learn more about those systems and the indications, you can watch the following videos. The performance page shows speeds and weights as computed and inserted into the FMS. The MISH page is for maintenance. The video page is reserved for external video cameras, but as far as I know, no aircraft has yet been equipped with this. The map page is an option that gives a detailed aerodrome chart with taxiways and parking stands. It is useful in low visibility. This area is called a memory panel or just memo panel and shows the status of fuel crossfeed, anti-icing, de-icing, and the cabin signs. The lower right part of the MFD is called a Virtual Control Panel, the VCP. It is connected to the RMS, Radio Management System, and is controlled with the Multi-Purpose Control Panel, the MCP. The arrow keys are used to move a cursor, shown as a cyan rectangle, and the numeric keys are used to enter frequencies. Most pilots find this more convenient than using the MCDU, but the MCDU has more functions. The COM push button toggles between VHF radios and, when installed, HF radios. The nav push button toggles between VOR and ILS, ADF, and a menu for information to be shown on the navigation display, such as TCAS vertical range, weather radar, terrain, airports, and nav aids. The surveillance push button toggles between the controls for the transponder and the TCAS. The weather radar control panel is located between the 2 MCDUs. The mode selector has 5 positions: off, standby, which is used during taxi and in flight when the weather radar is not in use; weather, which shows returns in green, yellow, red, and magenta; ground map, which shows returns in cyan, yellow, and magenta; and test, which shows this pattern on the ND. The tilt knob is used to adjust antenna from 15 degrees up to 15 degrees down. The tilt is shown on the ND. The gain knob is used to adjust the sensitivity of the radar. To do so, the knob must be pulled up. When the knob is pressed down, the sensitivity cannot be adjusted. The RCT push button activates the react mode. The weather radar detects raindrops, but when there is too much rain, the radar cannot penetrate the water and show what's behind. In react mode, the radar will show those areas in cyan. Such areas must be considered to be dangerous. The target push button activates the target mode, which is used when the navigation display does not show the weather radar. If a severe storm is detected ahead of the aircraft, the green target legend changes to amber. I don't have a picture because I never used this mode. The stab push button deactivates radar antenna pitch and roll stability. The weather radar is inhibited when the aircraft is on the ground, but it can be activated by pressing the stab push button 4 times within 3 seconds. This is useful when you line up on the runway and want to check for any weather that might affect your departure. The sector push button toggles between 120 degrees and 60 degree scan sectors. The weather radar cannot be shown when the terrain mode is in use. At the outer corner we have a clock. It has several modes. Here the upper display shows the time and the source is the GPS. Below is the elapsed time, which is activated by the first officer when we start to push back or taxi. That marks our block time. A push button on the glare shield starts a timer on the lower display. On standard T variants, the clock is removed. Instead, the timer is displayed on top of the memo panel and the elapsed time is displayed in the MCDU. The engine warning display is located on the central instrument panel. It is divided into 5 windows. 1. Primary engine instruments. That is torque, NP or propeller rotation speed, and ITT, the temperature inside the engine. Number 2. Fuel used for each engine. TAT, total air temperature, SAT, static air temperature, flight time, which is automatically activated at takeoff, and a clock, FOB, fuel on board, as calculated by the FMS, and finally gross weight as calculated by the FMS. Number 3. Trim and flaps indicators, plus annunciator for parking brake, TLU and anti-skid system. 4. Alert window, showing system failures. 5. Procedure window. Checklists are displayed here. On the AFIS control panel, we have 2 keys to move the cursor, which is marked with a cyan rectangle, up and down on the screen. The V push button means validate and is used to select the item marked with the cursor. Normal checklists are displayed automatically as the flight progresses. For example, when we have started the engines, the before taxi checklist pops up. You push the validate button and the checklist opens. As you go through the checklist, you push the validate push button and the item changes color to white and the cursor then moves to the next line. Procedure complete. The procedure menu push button opens the menu for the electronic checklists. The manual delete push button deletes active checklists, but only those that have been activated manually. The recall push button shows all active failures and their procedures, and the clear push button clears the alert and procedure windows. This is the standby instrument. It is called the IESI, the Integrated Electronic Standby Instrument. It has the following functions: artificial horizon, airspeed indicator, altitude indicator, VHF radio number 1, VOR ILS number 1, and course selector for the VOR. The IESI can be coupled to the autopilot, and it can fly on ILS. For heading indication, however, we rely on the old-fashioned magnetic compass, which folds out of the glare shield. Below is the power management selector and controls for the PEC, Propeller Electronic Control. They are described in this video. Further down, we have controls for the ice detector and a test push button. The ice detection system is described in this video. The stick pusher and shaker push button is used to deselect the system if the checklist calls for it. Otherwise, it remains on. The APM is part of the ice protection system, and is described in this video. Here we have controls for the EEC, Engine Electronic Control, and the ATPCS, Automatic Takeoff Power Control System. They are described in this video. Here is a placard showing some important speed limitations. VMO is maximum indicated airspeed. On the airspeed indicator, it's marked with a red and white band, called the Barber pole. MMO is maximum Mach number, which is a limitation at high altitudes. ATR doesn't have a Mach indicator, but the Barber pole will move and reduce VMO. VA is maximum maneuvering speed, which is maximum speed where you can apply maximum deflection of the flight controls. VLE is maximum speed with the landing gear extended. VLO is maximum speed when the landing gear is operating, which means lowering or retracting. VFE is maximum speed with flaps extended. Below we have the landing gear panel. There's a push button for the anti-skid and a test button. This is the primary landing gear indicator. When the panel is dark, the landing gear is up and locked. Red unlock lights indicate that it's in transit, and green triangles indicate that the gear is down and locked. There is a second indicator in the overhead panel. It is totally independent of the primary indicator. When at least one of the indicators shows 3 green, the gear is considered to be down and locked. The gear lever is shaped like a wheel and must be pulled out before it can be moved up or down. It is not possible to retract the landing gear on the ground. The lever cannot move. Next, we have panel for the automatic cabin pressurization system. It's very easy to use. Before you take off, you set the elevation of the destination airport rounded to the nearest hundreds of feet. The system does the rest. The down push button will open the outflow valves and must only be used when called for by a checklist. The descent rate push button, when pushed in, increases the descent rate for the cabin pressure from 400 feet per minute to 500 feet per minute. We use it when we are descending with more than 2000 feet per minute for a prolonged time. The ditch push button closes the outflow valves and is used when we are about to land on water. The other controls are for manual operation of the system. The pressurization system is described in this video. The side panels are located outside of the instrument panels. The side panel on the captain's side differs slightly from the side panel of the first officer's side. What they have in common are the following. A loudspeaker volume control. When the pilots are not wearing headset, the volume control should be set towards max. Otherwise, the volume can be set to minimum. Reading light and console light knobs. The switching panel. If one of the attitude heading reference systems, HSRS, fails, the affected ADI and heading indicators will fail. The pilot will then, in accordance with the checklist, push this button, which allows the system to receive information from the other HSRS. And if an air data computer, ADC, fails, the affected airspeed indicator, altimeter and vertical speed indicator will fail. The pilot will then, in accordance with the checklist, push this button, which allows for the system to receive information from the other air data computer. The display push button, it acts on DU number 2 and 4 respectively and allows to change the appearance between MFD, PFD and EWD. This is useful when one or more DUs have failed. If DU number 2 or 4 has failed, the push button acts on DU number 1 or 5. The audio select push button, it shows a fault light when the associated radio control audio unit, RCAU, has failed. That means that the audio control panel is inoperative, including radios and interphone. By pressing the push button, you activate the alternate mode, which connects the affected station directly to the respective VHF radio. Unique for the captain's side panel is the TOWS panel. TOWS stands for Terrain Awareness Warning System. The TOWS is also called Enhanced GPWS and is made of a GPWS plus terrain mode. The GPWS, Ground Proximity Warning System, alerts against rapid terrain closure, unsafe configuration at low altitude, excessive bank at low altitude, excessive deviation below ILS glide slope, and loss of altitude after takeoff. The terrain mode uses GPS and alerts about terrain ahead of the aircraft. Unique for the first officer's side panel is the elapsed time push button. It is activated to start the elapsed time counter. Ahead of each pilot, there are 3 lights on the glare shield. A warning light that flashes red when the master warning is activated. It is silenced by pressing the light. A caution light that flashes amber when the master caution is activated. It is silenced by pressing the light. The push button without a label is for the toes. An amber GPWS light is illuminated when the GPWS is triggered.
Terrain ahead. Terrain ahead.
A red pull-up light is illuminated when the toes triggers a pull-up alert.
Terrain ahead. Pull up. Terrain ahead. Pull up.
And here's a well-kept secret. When you push the button while the aircraft is on the ground, you activate the toes self-test. And when you push the button in flight, you silence the current alert.
Glide slope. Glide slope.
Finally, we have the Flight Guidance and Control Panel, the FGCP. I promise this is the last panel in this video. And this will be only an introduction, as a full description requires a comprehensive video. This panel allows the pilots to control the flight director, which provides steering commands for the pilots and the autopilot. Those 4 push buttons are for lateral or horizontal modes. When active, they display a vertical green bar on the ADI, and the active mode is shown in green on the FMA. The heading push button will cause the aircraft to follow the heading bug on the HSI, which is set with this rotating knob. When you push on the knob, the heading bug will move to the current heading. The nav push button will cause the aircraft to follow the navigation signal as selected with the nav source selector on the side where you have the coupling light. By pressing the coupling push button, you toggle between left and right side. Here, the first officer is pilot flying, and the flight director follows the signal from FMS number 2. When the navigation source is a VOR or a localizer, the mode will be armed until it meets the condition where it can be captured. The course for the VOR or localizer is set with those knobs, one for each side. When the FMS is active, the flight director will not arm the mode but activate it immediately. This mode is called LNAV, lateral navigation. The approach mode will arm both localizer and the glide slope. The BC push button is used to arm a localizer back course, which is an approach procedure where the localizer is used for an approach to the opposite runway. Very few airports have a back course procedure. Those 4 push buttons are for vertical modes. When active, they display a horizontal green bar on the ADI, and the active mode is shown in green on the FMA. IAS is indicated airspeed and is standard mode for takeoff and climb. The speed is controlled by the FMS or manually with the ICP. VS is vertical speed and is standard mode for descent. The rate of descent is set with this wheel. Before you start to climb or descend, you must set your target altitude with this knob. The selected altitude is shown above the altimeter. When the aircraft starts to climb or descend, altitude capture mode is automatically armed and is shown in cyan on the FMA. The aircraft will then level off automatically when reaching the selected altitude. The Alt push button is used to level off at the current altitude. The VNAV push button was introduced with Glass Cockpit Standard 2 variants. Earlier models did not have it. VNAV means vertical navigation mode and can only be used when LNAV is active. It will follow the published vertical profile for departure, arrival, and approach. When you are established on a LNAV VNAV approach, you can then press the up push button to arm the VFP, vertical flight path mode. The aircraft will then fly the approach like an ILS. Each pilot can switch off the flight director bars, but the flight director modes will still be active as shown on the FMA. The standby push button will cancel all flight director modes and engage basic modes, which are basically maintain heading and pitch. You can then adjust the pitch with the pitch wheel. The speed hold push button was intended to be used to maintain a constant speed by adjusting engine power during an ILS Cat 3 approach. However, no operators have ordered this option, and it has therefore not been developed. The yaw damper is activated after the landing gear is selected up, and it's disengaged shortly before landing. It provides a comfortable ride for the passengers and automatic rudder trim. The autopilot can be activated after takeoff as low as 100 feet. It must be disengaged at not lower than 160 feet on approach or 80 feet for ILS Cat 2 approach. That's all for this time. I hope you liked it. The next video will be about the instrument panels in ATR variants with EFIS cockpit. Then you can compare the two variants. Please support my channel by sharing with your friends, clicking like and subscribe so you don't miss the next video. You can also follow me on Facebook and give a donation with PayPal. See links below. Thank you for watching, have a wonderful day and happy landing!
以上就是 Magnar 机长超级专业的分享。要是这影片对你有帮助，记得按赞、分享、留言或订阅哟。祝你飞行愉快，我们下次见，拜拜。